on the orbitals which are involving in the hybridization, we are having different types of hybridization like sp, sp2, sp3, sp3d, sp3d2. Likewise, we are having different hybridized orbitals we are going to have. Okay. Uh, let's see one examples and how hybridization it will form, and what is the overlapping concept. Already we have discussed overlapping concept VBT, isn't it?
Yes,
Yes sir,
sir.
no, no, no.
Yes, sir.
Hello.
We discussed.
Hmm. So now that concept also will be helpful for us. Okay. For example, what we can say, depends on the type of hybridization involved. Okay. Hmm. You can see my screen, right?
Yes, sir.
Types of hybridization. Types of hybridization. First one, uh, SP hybridization. SP hybridization means what? In which one s orbital and one p orbital when involved in hybridization. Involves in hybridization. One s and one p orbital involved. So how many orbitals we will get?
Oh, sir.
Uh, gives two sp hybridized orbitals. Okay, two sp hybridized orbitals we are going to get. Okay, na? Uh, now see. So how this sp hybrid orbitals will be there, and what is the structure we are going to get? Let me see. Mm. One s orbital will be like this, right? We know s orbital will be spherical in shape, and one p orbital will be like this. Okay, which is given after the mixing, that is after hybridization process. We are going to get sp hybridized orbitals like this. Okay. See, which I am overwriting, no, that is one sp orbital, and which I am going to indicate with yellow color, no, that is one sp hybrid orbital. Okay, na, na, na? Right? So these are the two sp hybridized orbitals we can have. Likewise, we are going to have. Now, what is the example for this hybridization? Let me take example as BeCl2. Mm. So in this one, what is central atom? Beryllium is central atom, right? Beryllium having configuration of 1s to 2s2. So we are taking as a valence electronic configuration. We are taking.
Sir,
Hmm.
sir, didn't understand how one s orbital plus one p orbital became like that, sir.
I told you, no, intermixing of atomic orbitals means what? So when one s orbital and p orbital it intermix, we will get two orbitals, no? The two orbitals on say this area is intermixing, right? This area is intermixing. So obviously this area will be little bit larger, no, as compared to second area. So likewise, this is one sp orbital and one more sp orbital will be like this. Okay, that combination only I have written here. Okay, now
Okay, sir.
next one. Mm. Now see here. In this one, what is the valence electron configuration? It will be 2s2. And in beryllium, we can have 2p0 also there, no? Because 2p orbital will remain as it is. So if I'm taking this, that will have 2s2, 2p0. That is 2s will be like this.
So could you move the previous slide?
1 second, Anna. First listen, then I will go for this. And 2p orbitals will remain vacant. Uh, Okay. This is known as a ground state of electronic configuration. Ground state of etc.
Sir, that means the p orbital is 0, then it is known as ground state, sir.
No, whatever the original electronic configuration we will write now,
Yes, sir.
that will be remains always ground state electronic configuration only. For example, if I'm taking boron, boron is 1s2, 2s2, 2p1, right?
Yes, sir.
That will be ground state configuration. Now, here what we can say, one beryllium is forming two chlorines, two bonds, right? That means what we know, we need to form one bond, we need one electron each. So for that one, if I'm giving little bit energy, then what will become? The electron which is present in 2s orbital will become unpaired and it will go to next higher level, that is 2s and 2p. Because as they are having vacant orbitals in the same orbital, same cell, so the electron by giving energy which is paired electron, okay, which is paired electron will become unpaired. So this is what we can say about the first excited state.
Sir, so the beryllium here will have these two orbitals, sir.
Beryllium configuration is what? 1s to 2s to, no?
Yes, sir.
That means what? In that one, 2p cell also will be there, no? Second cell.
Yes, sir. It will be 0.
Because it is 0 means what? There is 2p orbitals. The 2p orbitals, okay, there will be 2p orbitals, but 2p orbitals are not going to be filled.
Sir, here 1s2 is not there, sir. That's the first shell we are gonna
But we
ignore.
are writing only valence electron configuration I'm taking, no?
Oh, okay, sir. This is
Okay.
valency
Uh,
joining.
yes. Now what will happen? These two orbitals will overlap.
Sir, once can you go to the previous slide?
Like this is one s orbital. First listen to me, then after that you will copy. First this is one s orbital and one p orbitals together giving this is sp hybridized orbitals. Okay. Now see, these two orbitals will overlapping, no? By overlapping what we will get? Sp hybridization it will involve. Likewise, this is one sp orbital, isn't it? One more sp orbital. Okay, one more sp orbital. Okay, students. This is what we can say about the sp hybrids. Now what we can say, this is provided by the beryllium. Okay. Now in case of chlorine, we are having what, 1s2, 2s2, 2p6, 3s2, 3p5. So if I'm taking valence electron configuration, what we can say, we can have 3s2 like this and 3p5 like this. Now this electron is there, no, p orbital, that will overlap. That means one p orbital of chlorine and another p orbital of another chlorine. These are for what? Chlorine atoms. And this is what we can say, as I said, overlapping zone, right? So this results beryllium, chlorine, chlorine bond. So what can be the hybridization between the orbitals? Tell me. So what is the bond angle between the hybrid orbital? 180, no? Because see, to understand only I'm giving this orbital diagram. Okay, na? To understand only I'm giving the orbital diagram, but actually in examinations just they will ask you what is the hybridization of the molecule. I will tell you how to calculate the hybridization and what are the tricks for it. Okay.
Sir,
Mm.
so in the diagram you shared two parts, sir, with the white lines. What is that?
This is what we can say intersection area, no? Like
Yes,
bond
sir.
information. We discussed, no, when overlapping is there, this is the common area which says
Yes, sir.
bond formation.
Sir, what is 180, sir?
180 degrees of angle, no? Bond angle. I told you, no, because of hybridization we can define bond angle also. Bond angle means what? The
Sir, how
angle
should we
between,
calculate bond angle, sir?
we can't calculate, it is like experiment quality only. Okay, na? Bond
Okay.
angle between the two hybrid orbitals will be 180 here. Okay. Likewise, we can say. Whereas if I'm taking one more hybridization, that is, if I want to show, 1 second, I will show you sp hybridized orbitals also. Please stay. Can you see? See, Nana? See, this is one s orbital. This is one p orbital, which is indicating with blue color. Can you see this area?
Yes, sir.
This one, which I am moving, no? This area. Now see which results. This is one sp orbital and this is one more sp orbitals. This one which is left side. See how my cursor is moving. Okay, na? The two orbitals only I represented like this. Okay, I have understood. So this is one larger surface and lot in between less area it is there. Okay, na? Now see these two orbitals are there, no? This is the purple color is there, no? This is the angle between the hybrid orbitals. That is what we can say 180 degrees of angle. Have you understood how the diagram looks and how we have drawn?
Sir, the small part is what, sir?
This is S part actually, because see this area is overlapping now. Let me show it on board once. This is S orbital, right? And in the p orbital, one part only get overlapping. No, these two only getting overlapping. No,
Yes, sir.
that means what? This area will become larger, and this area which I am indicating with three lines, that will remains
Small,
as
sir.
it is only. No,
As
Eh,
compared to left part, it will be smaller, sir.
that's why I have written like this. Okay. Mm. This is what we can say sp hybridized orbitals. Okay, na students.
Okay, sir.
Mm. Now from this one only we are going to write to sp. So have you understood this example and how it looks? Linear structure, no? So if the sp hybridization is there, the molecule is linear. Okay, BeCl2 hybridization is sp and the stoichiometry will be linear.
Sir,
Second
one
type of
minute, sir.
hybridization is sp2. Okay. In sp2, how many s orbital will involve? How many s orbital will be involved? In sp means what? 1s and 1p. In sp2 means 1s and 2p, right?
Sir,
Hello.
I don't understand.
And the sp orbitals means what we can say?
One S and one P, sir.
sp2 means what we can say? 1s
Two
and 2p
P's and
orbitals,
one
no?
S, sir.
Yes or no?
Yes, sir. One S, two P's.
That means what we can say in this hybridization. In this hybridization, one s and two p orbitals will involve. Two p orbitals intermix together to form. How many sp hybrid orbitals will form? sp2
Four, sir.
4. 1s and 2p. How many? 3 orbitals or how many orbitals?
Three, sir. Three.
That means how many orbitals will involve in hybridization? 3
Three.
sp2
Yes, sir.
hybridized orbitals will
3 sp
involve.
square.
Sorry, hybridized orbitals forms. Okay, na? So how it
Sir,
will be?
1 SP2P means 3 SP2, sir.
Arey yaar, we have in rules only we said no. If two orbitals are involved in the hybridization, we will get two hybridized orbitals with equal energy. If three orbitals are involved, it will give three hybridized orbitals. If four orbitals are involved in hybridization, four hybridized orbitals we will get. This we have discussed, no, in rule
Yes, sir.
only.
In the first case, two orbitals are involved, na, sir.
Mm,
That's why we got two, sir.
mm,
Okay, sir.
In sp2, what we can say? We can have one s orbital. Okay.
Two P orbitals.
Uh, so this is one p orbital and one more p orbital will involve. Okay. By in these all are belongs to same atom, no?
Yes, sir.
So by involving this, what we will get? We will get
Flower.
three sp2 hybridized orbitals will be like this.
Sir, like flower shape.
Yes.
In the center is
Okay. Likewise, we can write like this. So this is there, no? This is outside part actually. That means this is one sp2. Likewise. Okay. Likewise, we can say
two P's are there means we have to get like four petals, na, sir.
four petals how it is. Three parts, no? One part, this is one part, and one part. For example, if I
Two
want to
loops
show,
combined means.
huh?
Sir, if two loops are combined, we get fourness.
No, not two loops, not will not combine, no.
Okay, only the ends, sir. Sigma bond.
Yes. Hybridized. Sorry. See this one. Okay. Because p we can write like this, no? Two p orbitals we can write. Understood, Anna? So likewise we will get.
Sir, we wrote 2p orbitals as 2px and 2py, sir.
Actually, two p orbitals means two px. Generally, p orbital starts from uh, second cell only, no? And p
Yes, sir.
orbitals will have px, py, pz. So that one I have taken two px plus two py. Okay. Now see here. Mm. Now these orbitals are there, no? This is sp hybrid orbitals. Example, if I'm taking now BCl3, we will get. In that one, what is the central atom?
Sir,
Boron, sir.
boron. Boron.
Boron, right? What is the boron configuration?
1s2, 2s2, sir.
Boron
Sir,
what?
1 2 2s2
1s2,
2p1.
2s2, 2p1.
1s2, 2s2, 2p1. So as we are taking valence electron configuration, what is the valence electron configuration?
Sir,
EC
2s to
means
2p1.
electron configuration. Okay, na?
2s2, 2p1, sir.
2s2, 2p1. That means how we will write, likewise we will write, no? That means what we can say here, what we can say, PCl3. That means one boron combines with the three chlorine atoms, isn't it?
Yes, sir.
Yes.
Mm. That means how many unpaired electrons required? Three bonds it is
Three.
forming, no?
Yes, sir.
So that means
Three.
three unpaired electrons required. So this we can write as ground state of electronic configuration.
Sir, I didn't understand what is the meaning of ground state of electrons, sir.
Who is asking?
Ritvik, sir.
In first example also I said, no? Ground state means the original electronic configuration which we are writing for the individual atom. Okay, na?
Okay, sir.
Whereas excited state means what we can say?
We distribute from 2 to s to
Uh,
p orbitals, sir.
that
One
means
will
what?
go to
The
the
which
next
is there?
orbital.
The paired electron in the same cell. If we are having vacant orbital, it will become unpaired. This is what we can say first excited state.
Sir, as compared to the ground state of electronic configuration, first excited state is more stable, na, sir?
Not like that. More stable we can't say. That means we are saying that, okay. So this bond which is saying that BCl3 is there, no? That is going to form in excited state of configuration only. Okay, na?
Okay, sir.
Mm. Done?
Done, sir.
Okay. Now these three orbitals will involve in hybridization to form sp2 hybridization. Okay, na? sp2 hybridization means what we can say. So as I told you, it will form, and chlorine having how much, Nana? It will have 1s2, 2s2, 2p5 as it is. Sorry, 2p6, 3s2, 3p5. So valency configuration. See, whenever we are writing, no, generally we will take for valency electronic configuration only we will take. Okay, na? Now these sp2 orbitals, how it will be there? Like this, it will be there, no? Okay, this is boron sp2 orbitals, and now if I'm taking these orbitals will overlap with the s orbital of p orbital of chlorine. Likewise. Now see this intersecting area which we can say as a bond formation. Now if you are observing how it is looking like structure, like planar structure, it is looking like or not? Like this structure is similar to like this only, no? If I'm taking write this, let me write. So the central atom will be this, and this is one bond, this is one bond, and this is one more bond. How it is looking, Nana? Like a trigonal planar, it is looking, no? Like triangle. Hello.
Yes, sir. Yes.
That means what we can say, sp2 hybridization geometry is trigonal planar.
Sir, this is sp2, sir.
Uh,
Sir, sp2 at the end, why it will have one more p orbitals, sir?
Arey yaar, it is not sp2. This is the structure of bcl3. So this
Oh, oh.
boron halides, which I am indicating with this color, no? Let me write color change. This p orbitals, no? This sp hybridized orbitals will overlap together to form one pi bond.
Okay, sir. sp2, 1 and 3 sps.
Yes.
Okay.
Okay. Uh, and the bond angle will be how much? Bond angle will be
90 degrees, sir.
90. Yeah. This is planar, no? Triangle 120 degrees.
Sir, can you once again explain triangle planar?
Trigonal planar, Nana.
Yes, sir, trigonal planar.
Actually, this is sp2 hybrid orbitals, right?
Yes, sir.
Uh, how it will be there? It will be like this, isn't it?
Yes, sir, like a flower.
Like a wings of a fan.
Sir?
Wings,
Yes, sir.
fan wings. Now this is
Yes,
central atom, and this is the sp2 hybrid orbitals. Okay,
yes,
this
sir.
is one sp2 hybrid orbital. Likewise, we can have three sp2 hybrid orbitals, isn't it?
Yes, sir.
Now these three orbitals will overlap with the p orbital of chlorine atoms. That means the center one is for boron, and this is for chlorine, this is for chlorine another, and this is for chlorine. That means simply how it looks like: boron, one chlorine, one chlorine, and one chlorine. This is how it looks like. The if I'm combining all the corners, it is looking like a
Triangle, sir.
triangle, no? This triangle
Yes.
other name only trigonal planar we can say. Okay.
Yes, sir.
Mm.
Sir,
Have you
how
written?
can we, sir, how can we identify that This is trigonal planet, and this is
That I will tell you one trick. I will tell you. Okay. At last, after all this, okay, na?
sir. Bond angle is fixed for anything, sir.
As for molecules, no bond angle is fixed only.
Sir, what you wrote? Bond angle 120 degrees C.
No, not Celsius. No, it is 120 degrees. Okay, na?
Sir, Ritvik kept a message.
Huh?
Ritvik kept a message.
Sir, I'm not understanding how to draw this formation, sir.
Actually, see, these formations, no, you need to practice only. On time, you can't write only. Okay. By practicing only, you can write. Actually, what I'm trying to say, so this type of diagrams we are going to find. But actually, in examination, objective examinations, they will not ask you these diagrams. Just straight away, they will ask you the hybridization examples.
Sir, can you go to once previous?
Next hybridization is okay. Complete it first.
Sir, and one more, I'm not understanding how can we find the bond angle, sir?
Bond angle is experimentally we can define. We can't. There is no any specific method to calculate anything. Okay, na? It is experimental data only.
Okay, sir.
Done.
Done, sir.
Next. Next type of hybridization is sp3 hybridization. In this one, what we can say, Nana? How many s orbital?
Sir, one s orbital and three orbital.
One S and 3 P, sir.
So in this,
So that's 4 orbitals.
1s and 3p
Four
orbitals
hybridized orbitals, sir.
intermixed together.
Sir, here four orbitals are used,
Four
sir.
4sp3 hybridized are formed. Okay. So how it will form? See, one s orbital plus 3p orbitals. No, this is on px orbital plus py orbital like this, and pz orbital. This all intermixed together to form 4sp3 hybrid orbitals. Okay. The which I am writing inside load small part, no, that is like other part of the atom. That means let me see sp3
Sir,
hybrid. 1 second. Like I see sp3 orbitals you are saying, no, see, Nana, sp3. 1 second, I will show you sp3 hybrid orbitals. Can you see this sp3 how it is looking? 3D shapes, can you see or not? Can you observe?
Yes, sir.
1 second, I will show you sp3d, sp3 hybridized. On rectangle, sp3, sp3, sp2.
Sir,
Ah,
once you can search SP3, sir.
that
It
all
is
I'm showing.
searching.
See here. sp3 hybrid orbitals. Can you see this table?
Yes, sir.
See how it is forming. Like, see this diagram, which top right. See na? Okay. So this is hybridized orbitals. So by this one only we can find. This is like how it will be there if I'm taking no. So this is central atom, and one bond will be like this. So this is nothing but what we can say, like tetrahedral geometry we can say. So if we are combining all this, no, how it looks, it's like tetrahedron it is looking, no.
Yes, sir.
That's why sp3 hybridization means what we can say. Geometry is tetrahedral, and bond angle is 109 28 109 degree 28 minutes. Okay. Example we can say about the CH4 we can say. Will you try in CH4 how hybridization sp3 will be there?
Sir,
uh,
sir, bond angle is
Bond angle
108.28, sir.
109 degree 28 minutes. Okay, na?
The first is like the valency of C, sir. Electronic configuration.
Okay. Then after that, please tell me correct. Okay. See, simply carbon valence is what? 1s2 2s2 2p2, right? So this is what we can say ground state.
2s to 2p2. 2s to 2p2 is a valency, sir.
So 2s2 and 2p2 will be valence electron configuration. Okay, na? Valence electron configuration. In first excited state, what we can say? We'll say like this. Now these four will involve in hybridization to form sp3. Okay. This is what we can say about the hybridization, and each electron, each orbital sp3 hybrid orbital, which will overlap with the s orbital of hydrogen. Okay, Nana? So likewise, we are going to find sp3 orbitals.
Sir,
Mm.
sir, so if we combine different elements, also the bond angle will be the same, right?
Yes, in between any molecule, if the molecule having same hybridization, it will have 109 28 minutes if it is sp3.
Okay, sir.
Okay. Okay,
Sir, why
students.
20, sir, why 28 minutes came, sir?
Angle, Nana, angle, how it is, YK means what should I answer? This is the hybrid orbitals, right?
Yes, sir.
This angle is this value. By using that protector or anything, no, that value is 10. 28 minutes means what? Which is similar to 109.5. 109.5 degree, nearly.
Okay, sir. Thank you, sir.
Okay.
Yes, sir.
Okay, students. Then we will meet tomorrow. Bye.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night,
Thank
sir.
you, sir. Bye, sir. Good night, sir.